Let's do a little bit of advent of code here. This is a great site, a great set of challenges. Way better, in my opinion, than doing lead code. And it kind of mimics the style of interview that you can expect to get as a software engineer, especially if you're going for more like, well, actually going for any role, to be honest. I think these are just great set of questions. They're not easy and they give a lot of context, and they have like these weird stories that are Christmas themed with elves and stuff like that. I've never made it through all 30 days, but the first couple of days are usually fairly approachable, and this is a really good like test of your skills, because when you go to an interview, it's unlikely they're going to say, hey, this is a binary search problem, or this is like a tree problem, or whatever. They're going to give you some problem, and it's up to you to figure out what's a good way for me to approach this problem. And this is like, people sometimes call these algorithm style interviews. I just call these like logical interviews. And there are algorithms to approach these problems, but there's no hard and fast rule that says you need to know XYZ algorithm to do it. It will help for sure. So we're going to try this problem out together. And I have a little bit of setup already done. So I don't think I'm just doing this like completely freestyling it. I definitely had some time to kind of figure out how I was going to approach this problem. But these are pretty long. I'm not going to read the whole thing. That's ridiculous. What you really want to read here are the input here and what the output is, and some of the edge cases that we need to consider as we're crafting a solution here. So it's a whole story about elves and stuff, right? Then it goes into like, here's the example. We get the first digit and the last digit in that order to form a single 2-digit number. So for example, this would be 12. Like you see the 1 and the 2 are on opposite ends, right? And then you see PQR3. Okay, that's 1 in 8, 38. Now here's an interesting one. We have 1, then 2, then 3, then 4, then 5. But the number here would be 15, like it tells you here, because you only get the first, you get the outermost numbers. So you get the, you get that on the outermost edges, you want to get the numbers. And then finally, here's another interesting one where you have a 7. And because you only have one 7, it ends up being 77. And in that case, you would add these all up. So you take the numbers, you don't sum the numbers, you get the numbers, and then like you sum them all at a time. And so we have a couple edge cases here. One is that you have one number. It looks like you can always expect to have one number, and it looks like if you have more than one number, you only take the most right and the most far left. Take the inner and outer bounds of that, and then you add them all up. Okay, sounds like we kind of understand the problem. So let's see how we do this. So here's the example, and we want to get the input. Where's the input? Get your puzzle input. Now the puzzle input they give you is like a big block of text. So what I've done is I put this in an input.txt file, and then I use the file system just to read it and then parse it into something we can actually use. So now we have something that looks like this. If I do console.log data and we run this, you'll see that the data is now something we can actually use. It's an array full of strings, and now we can mess around with it. One other thing I might do if like doing this and I want to just not like look at the entire answer, because there's a ton of stuff in here, maybe we just start off with like a few, you know what I mean? Like let's just start off with like 3, right? So let's start like, okay, this would be 99 and then 34 and 99. That sounds reasonable. Let's just like remove the rest for now and just get them out of here. And let's now mess around and think of how we're going to do this. So to me, this seems like a 2-pointer type of solution that we're going to end up having to do. A 2-pointer means we're going to have like a pointer on this end and a pointer on this end, at the leftmost and the rightmost. We're going to get those pointers to increment on the left side and decrement on the right side, right? Until we keep looking until we find a number. When we find the leftmost, we stop. When we find the rightmost, we stop. And if we don't find something on the like left or right, we'll just keep incrementing until we do. So we have a couple things that we need to like consider. The cases where we only have one number, I think that should satisfy that. In the case where we have multiple numbers, that's actually a little bit easier. But I think we kind of already know what to do a little bit. Like I may not know exactly how to solve this, but I know a bit of how. I know that we want to have 2 pointers. We want to have 2 ways to tell where we are within the item in the array. And the first thing, of course, we're going to do is have to iterate over the array. So might as well just start right there. All right, let's just start iterating over the array. So do like for let, I equals 0. A lot of you would fail right here, which is a real shame. You can't. One thing I hate when I'm doing interviews is somebody doesn't know how to do a for loop, and they're like, I don't know how to do a for loop. I'm like, well, like, you can look up all sorts of stuff, but not a freaking for loop. That's ridiculous. Okay, so now we're iterating, and now we're going to get the current string that we're going to be looking at, and that's going to be data at index I. And then what else? Now, this is the two-pointer part where we get the leftmost and the rightmost indexes, indices. So let's do that. So like const, or actually let, because we're going to increment these. So we'll do like let start and finish. I'm just destructuring these to be cool because I am cool. Natch equals data 0, right, for the first index, and data I dot length, or no, cur string dot length -1. So now that we have our start and finish, we have a check that we'll need to do to know, like, are we done, or should we keep going? And this is like just some boilerplate kind of stuff. Like, this is your typical two-pointer solution where you're going to be incrementing the left side and decrementing the right side, like we kind of talked about. So like, you know that you are finished, that you can't go any further. You know that there's a point where you just have to stop. Like, and that's usually when the start is less than or equal to the finish. So for example, if you go like 0 and you go 1, and then you go, okay, the length is like, let's say 3, and you go 2, and then eventually they'll both end at 2 or something like that, and you say, okay, we're done. We can't keep going, or else we'll be in a bad spot. So that's one thing that I know we'll have to do to prevent us having like a forever loop. So while the start is less than or equal to the finish, we'll do some stuff. And now we need to do another check. We'll be like, if the cur string at the current pointer is a number. So how do we do that? We need to check, like, is this thing a number? So like number dot is integer plus, and we'll do plus to coerce this to a number. Don't get too like caught up in like the way I'm doing. I'm just trying to think like, what do I want to check? Like, I want to check, is this a number? If it is a number, then I know we found the leftmost pointer. And then I know we need to keep track of that somehow, because we need to keep the leftmost and the rightmost number. We need to store those somehow. So I think we need some more variables in order to like keep things going on. So we have let leftmost equals like an empty string, and let rightmost equals an empty string. And so the leftmost will be equal to the cur string at the start, right? And then we can basically copy this, because the same thing's going to happen for the other one, right? So if we have like, okay, if cur string at end, then the rightmost is going to be cur string at the end. This kind of works, I think. So we have a couple weird things going on. So because if we find the leftmost, we don't want to keep looking anymore. So we know we're done looking at that point. We don't want to keep going. So if the number is whatever. So basically, if we haven't found a leftmost, if we have not found a leftmost, then start ++. And if we haven't found a rightmost, so if we do not have a rightmost, we need to keep looking for it. So now we're telling our algorithm like when to increment or decrement. And this is almost right, because while the start is less than the finish, like it's at some point, if we only find one number, then we'll keep decrementing like the right or the left till we just meet in the middle somewhere. Like we meet, like if, for example, let me find an example here, like with 9, right? We'd find the start here. We'd be, oh, cool, we got 9. And then we'd keep needing to go down, bam. And we'd meet right there again, and we'd be done, right? But like in this one, 86, it looks like, this is at 886, we'd go, okay, up, boom, we found 8, done. Then on this side, we go, okay, down, we hit 6, done. But we'll never actually meet in the middle in this case. So we need to also have another check when, like, if the start is less than the finish, or I don't know, or there's no leftmost, or there's no rightmost, right? I think that takes care of all the things we're looking for. Let me make sure this is like going to work. So while the start is less than the finish, or there's no leftmost, or there's no rightmost, I think that should be all of them that we need to do. Now, like at the end, we need to like keep a track of the sum too. It looks like, because like eventually we're gonna need to like sum this all up. So we'll put like a let sum equals 0 to start. Well, I don't know why not. And then we'll do this. We'll do sum plus equals, and we will do the leftmost. Remember, these are strings, and we'll do rightmost. And because these are strings, we will like coerce it to a number by adding a plus in there. You could do it some other way if you want. You could do like this too, I guess. You could do number. Why not? I don't know. Does it matter? Let's walk through this real quick just to make sure we're doing this right. I mean, it doesn't really matter. Screw it. Let's press run. Let's press run and see what the hell happens. Curse string end is not defined, and that's because I put finish. I don't like finish. I like end. Let's use that instead. While start is less than end. Do we have any more finishes in here? No, we don't. Cool. Let's run it. Okay, it didn't like blow up, but I think we're also not console logging the sum. So let's console log the sum. And this while we're in a while, we don't want it in here, do we? No, we don't want it in here. We want it in here. So let's console log the sum at the end and see what the sum is and see like, are we done? Let's run it again. Ooh, stop. Ooh, that's not good. That means that there's some sort of bug in here where it's not like stopping. So while start is less than the end, and we don't have a we don't have a left, not a left or. I kind of hate these stupid things like this where we're like looking at these statements, because basically we want to make sure like we have a few conditions. Like one, the start is less than or equal to the end, and or really or, because like or there's not a leftmost or a rightmost. So we could put like or, I guess. This makes more sense intuitively to me. Like while the start is less than the end, or we don't have a leftmost and we don't have a rightmost, then that seems like we should keep looking for stuff, right? That makes sense to me. But let's stop this so we can actually play it again and like make sure that this works. Now where's the button to freaking do? Oh, stop. Yeah, just stop it. That's ridiculous. Okay. What is going on here? End minus minus. If there's no leftmost, start plus plus. Oh, okay. And if the number is integer and there's no rightmost, we don't even want to look in there in that case. And if the number is an integer and there's no leftmost, okay, because like we don't want to just keep looking around. So we have rightmost, leftmost, we have the sum. We say if there's no rightmost, end minus minus. If there's no leftmost, start plus plus. And then we look if things are numbers, and we say, well, the start is less than or equal to the end, or there's no leftmost and no rightmost. Then we should be looking for stuff. We could also put a console log in here. I'm just curious, like, what the hell is going on here? So let's put like start and end in here. Just see like what is going on here. Something's up. Oh, look at that. Okay, so that's obviously not right. There's something wrong in this statement here. While the start is less than the end, so start plus plus, end minus minus. While the start, this is so weird. While the start is less than or equal to the end, or or there's no leftmost, or there's no rightmost. Yeah, I really don't like the stupid thing here. That's really annoying because the end. This is so weird. While the start is less than the. Oh, look at that. Look at that. The end just keeps going. It just keeps going. The start never increments because on that first one, if we look at the first one, we have 9. And then we say, okay, well, start is less than or equal to the end. Well, start is less than or equal to the end. This is so weird because I would think that would just work, right? And now I'll be honest, I'm kind of like just throwing junk at it right now, which I don't like because I'm like, something's not right here. Console.log sum. Okay. Blibbity blop. We have the sum here in the for loop. That shouldn't be in the for loop. That should be outside the for loop. And let's see. First of all, I don't like the fact that this stopped because I've seemed to have fixed something, but I'm not exactly sure what I've fixed. Okay, the sum here is 29. Okay, the start and the end. Okay, let's check this out here real quick. Let's just see what we got going on here. I also just want to see this part. Console log leftmost and rightmost. And let's get rid of this console log in here because we don't care really about that. And let's see like what we get here. This will tell us if we actually got it right. Leftmost, rightmost, and we almost got it right, except we know this should be 99, this should be 34, and this should be 99 again, and this should be 86. Something is wrong with our rightmost one. If the integer is cursed, oh, stupid. These stupid things. Look at that. I have the wrong thing. Okay, let's run this. Let's run this now. There we go. That's what I'm talking about. 99, 34, 99, 86. I like this answer so far. Look at this, an empty string. We just, whatever. It's stupid. It makes no zero freaking sense. But what I don't like here is this part. While the start is less than the end, less than equal to, and there's no leftmost or rightmost. So if there's no leftmost, we start plus plus. If there's no rightmost, we end in it. You know what we could do? We probably just get rid of this, right? I mean, we could just keep incrementing them down, and we could just not actually update them here. I don't really like that because it seemed like we could bail early on this one. Like if we found the left and we found the right, we're done, right? So like if we found the left and we found the right, so it seems like if either here or there's no leftmost and there's no rightmost. I think that makes more sense in my head. Let's just see if it even works. Okay, kind of. Okay, and there's no rightmost. If the number is an integer and there's no rightmost, then the rightmost equals curve string, and then we do n minus minus. Or there's no leftmost, or there's no rightmost. Okay, how about that? What about that? Still don't like it. Okay, let's go back to what it was. Still, I'm not really satisfied with that. It certainly seems to work, but I'm not like super satisfied with it. And I'm gonna go back one more. Okay, if there's no rightmost, blah 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 blah. Let's run it again. Let's make sure we get the right thing here. What the hell did I just do? Okay, come on, go back to it. Okay, that looks cool. Okay, so we have 318, and I feel like this is pretty good. I'm still just not really happy with that part about here where I don't really get why, but maybe it's late, maybe just not really catching it. But I think we've satisfied all the conditions here, and if I ran this with the input, all of it, I'm pretty confident I have the right answer. I don't want to spoil the fun for you, so of course you should try this on your own and see how you did it and maybe how you could improve on the approach. But again, ultimately, we used a 2-pointer solution, and then we just had a bunch of like kind of weird edgy cases to check on during that. But again, that 2-pointer thing is really the crux of this problem. Hope that was helpful for you, and good luck doing Advent of Code, and have fun out there. See ya.